In this video, I'm going to be discussing molecular geometry. So this example states, give the number of lone pairs around the central atom and the molecular geometry of XeF4. When solving these problems, it is important to first find the total number of valence electrons by looking at the periodic table. So you need to break down your compound. Xe is in group 8, so that tells us that there is 8 valence electrons. F is in group 7, but there are 4 fluorines, so we would see that there is 7 electrons times 4 would give us 28. Now we add the total number of electrons. That gives us a total number of 36 valence electrons. So we know that our structure needs to have 36 electrons. We first identify our central atom. We know that since there are 4 fluorines, that Xe must be our central atom because fluorine cannot be. So once we do that, we begin to connect it with 2 electrons. Each bond represents 2 electrons. So that would give us 2, 4, 6, 8 electrons so far. After doing this, we notice that fluorine needs to fulfill the octet rule, meaning that there must be 8 valence electrons surrounding fluorine. So once we fill those electrons in, we would get 8, 16, 24, 32. That leaves us with 4 more electrons. This is when lone pairs come in. Because there are extra electrons, all we do is place 2 lone pairs, which consist of 4 electrons in total, around Xe. So this gives us a total number of 36 valence electrons. After drawing our structure, we can see that XeF4 has 2 lone pairs and its molecular geometry is square planar.